Okay, this is, before we jump into solving more complicated trig equations, I want to remind you how we used to solve quadratic equations. So quadratic equations are simply polynomials where the highest degree is 2. So they take this form. So there was 4 main methods you learned in college algebra about how to solve these. Factoring is one. Another method you learned was quadratic formula. This is everybody's favorite, completing the square. I'm just joking. Usually people don't like that. And then sometimes it would be in a very nice form we were able just to take the square root, taking the square root. All right. So, factoring is generally the best way to go when you're dealing with trig equations. So I'm going to concentrate on reminding you how to factor or teaching you how to factor. And if you're already good at it, you can use your own method. You just got to make sure you're doing it right if you have a better method, and that's fine. Also, quadratic formula. Let's just mention what quadratic formula is. It's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. These a's and b's and c's are these coefficients when your quadratic function is written in this form. Okay, so that's the quadratic formula. Factoring. This is where I want to spend most of our time in this video. What is factoring? It is basically just rewriting something into multiplied form. Factors are things that are multiplied together. That's what factors are. So there are different methods of factoring, and I've given us some practice ones to recall how to do these. If you have a polynomial such as number 7, that is a form difference of squares. That's one type of factoring. If you look at 8, 9, 10, and 11, each of these are trinomials. I will be using a method called the AC method to factor those. If you look at number 12, this is not difference of squares, this is difference of cubes. And so maybe I will change this from 1, I want to change this to the number 27 just to illustrate this. This is something being cubed. Often you'll see a 1 there. 1 is so easy. 1 to the 5th is 1. 1 to the 20th is 1. But I just, for illustrative purposes, I'm going to change that to a 27. Okay. 13. This one does not fit in a special form, but this is just regular old factor out the greatest factor. So I threw that one in there so that you could be aware that don't forget that method. All right. How do you solve? What we're trying to do is figure out how to solve equations. So if we solve by factoring, this is all based on the zero product property. If you recall the zero product means multiply, property. And so these are not equations. We're just going to factor these. But how would we take the next step into solving these? This is based on the fact that if you're multiplying things together and it equals to 0, the only way this is true is if one of the factors you're multiplying is 0. So you set those to 0 and solve for x. So we're just going to factor here, but down here we're going to solve equations. So we got to remember how to finish the process. Okay, number 7. Let's just factor this. We have x squared. You know what? I shouldn't have put a 1 because I put 1. 1 is nice. The square root of 1 is 1. Let's make this more exciting. This is super exciting. There's a 25. X squared minus 25. We're going to factor that guy. All right. If you think this is difference of squares, and it is, this is your test. This is the form that the difference of squares takes. Can I take the square root of the first thing? Can I take the square root of x squared? Yes, I can. Can I take the square root of the second guy? Can I take the square root of 25? Yes, I can. It would be 5. Is there a minus in the middle? Yes, there is. Then you're staring at difference of squares, and this factors into a minus b times a plus b, or vice versa. You could change the order of that. This will factor into x minus 5 times x plus 5. We factored that by recognizing this was difference of squares. Let's do number 13 real quick. 13 is this. If you've got x squared plus 8x, this does not fit a common pattern. However, I notice there's a common factor in both of these. I can factor out an x, leaving me with x plus 8. And so I have factored this. I've rewritten it in multiplied form. This times this. The top one changed into this times this. We factored that, wrote it as multiplication. Let's do number 12 while we're at it. Number 12 is v to the third minus 27. This is different subtraction of two things being cubed. A cubed minus b cubed. You could also do it if there's a plus. We have a formula for the sum of cubes as well. We don't have sum of squares. That does not factor with real numbers. So how this would factor into, by formula, a minus b times a squared plus ab plus b squared. This is just a formula. So you ask yourself, is this form? Can I take the square root of v cubed? And I can. The cube root of v cubed, I said square root. The cube root of v cubed is v. Can I take the cube root of 27? I can, because 3 to the third power is 27. And is there a minus in the middle? And there is. It's going to follow this pattern. So in this case, a would be v. B would be 3, because 3 cubed is 27. So it's going to be, this factors into a minus b. Oops, I meant to write 3 times a squared plus a times b, 3 times v, plus b squared. And that's how you would factor number 12. All right, let's deal with these trinomials. Number 8 is m squared minus 2m plus 1. Number 9 is 4c squared plus c minus 3. Number 10 is 2m squared plus 3m plus 1. And number 11 is c squared plus 12c plus 20. All right, I'm going to start with the, I guess, the more difficult ones, and none of these are all that hard, but I'm going to start with the longer process. So I'm going to start with 9, and I will do that on this piece of paper right here. I'll do my thinking. 4c squared plus c minus 3 is like a x squared plus bx plus c. I'm going to use the AC method for factoring. So in the AC method for factoring, you take a and you multiply it times c. So in this case, I'm going to take 4 times negative 3, which is negative 12. I take a times c. And then I want to find two things that would add up to be b. So what is b? It's the coefficient in front of the c, which is just a 1. I have to find two things that would multiply to be a negative 12. I have to multiply a positive times a negative to get a negative 12. And the bigger number of my factor needs to be a positive if I want it to add up to be a positive 1. So I think about the factors of 12, and I finally come up with that 4 times negative 3 would give me negative 12. And if I take 4 plus negative 3, I get a positive 1. So these are the winning numbers. Now, once you have the winning numbers, if a is not 1, what was a? It's 4. You need to rewrite the middle term, positive c, into 4c minus 3c, which gives you positive c. So this little rewriting of the middle term has to occur. So we have 4c squared plus 4c minus 3c. See, these are equivalent to this. And then copy this guy down, minus 3. So I copied down the first term, I rewrote the middle term into two terms, and then I copied down the last term. Now you finish this factoring by grouping the first two terms together and the last two terms together. What is the greatest common factor I can pull out of this? 4 times c. If I factor out a 4 times c, it's like you divided it. I'm left with the c plus 1. What is the greatest factor I can pull out of there? If there's a negative there, you have to take the negative 1 and anything else that will go. So a negative 3 will go out of that. If I divide this by negative 3, I have a positive c plus 1. So this will factor into, you take the common factor of c plus 1, you factor it out, and that leaves you with a 4c minus 3. This is factored. That's how we can factor number 9. Can you check your factoring? Of course, you can multiply this back together. C times 4c is 4c squared. Positive 4c minus 3c is positive c. 1 times negative 3 is negative 3. Okay, I started with the more complicated ones. I'm going to go to the easier ones in a second. Let's do number 10. A is 2. Okay, B is 3. C is 1. I'm going to use the AC method. A times C is 2. I want two things. I can multiply together to get 2, but add together to get 3. And so this is pretty straightforward. 2 and 1. 2 times 1 gives me 2. 2 plus 1 gives me 3. So I rewrite the middle term. So 2m squared plus 2m plus 1m plus 1. Then I group. Then I factor out the greatest common factor. 2m leaves me with the m plus 1. There's nothing to factor out here. That's fine. So now I factor out the m plus 1. What's in front of this, though, is a 1. So be aware of that. When I factor out the m plus 1, I'm left with a 2m plus this 1 right here. You can always check. M times 2m is 2m squared. 2m plus 1m is 3m. 1 times 1 is 1. So that factors nicely. If you factored it and you got it in the reverse order, that still is completely correct. Okay, number 8 and number 11, I saved those because those are pretty straightforward. If A is 1, you can skip the step of rewriting the middle term. You can just say A is 1 and C is 1. So 1 times 1 is 1. I need two factors that will multiply to be 1 but add to be negative 2. The only thing I can think of is a negative times a negative. Negative 1 times negative 1 is 1. Negative 1 plus negative 1 is negative 2. So that works. So you can rewrite the middle term, but you don't have to if the leading coefficient is 1. If it's 1, you can write this straight in factored form. It's going to be m minus 1 times m minus 1. Now this one happened to be a perfect square, so if you want to write it as m minus 1 squared, you certainly can. Let's do that again. Let's look at 11. A, the leading coefficient, is 1, so that means I don't have to rewrite the middle term. I can do the fast way. B is 12, and C is 20. A times C is 20. I need two factors that will multiply to be 20, but will add up to be 12, and you think about that, and you come up with, eventually you'll say, oh, 10 times 2? 10 times 2 is 20. 10 plus 2 is 12. Since A is 1, I don't have to rewrite the middle term. I can factor this directly into C plus 10 times C plus 2. And you can check your work by multiplying that back together. So that is factoring. Let's pretend for a second they didn't say factor, but they said solve. And they said equals 0. So what you do is you factor the left-hand side, and it's equal to 0. And you say, well, when will this be true? Well, the zero product property says this is true when either this term, 2m plus 1, is 0, or this term is 0. When m is negative 1, or when 2m is negative 1, or m is negative 1/2. So that's how you finish solving by factoring. I spent more time on factoring because when it comes to trig functions, if you can factor this, it makes it much easier than using a different method. All right, that's that one.